Hello, I'm going to explain my Connect4 game. This will be a front end for Connect4 in TUI, which is like GUI but in terminal. And this is some of the details from Wikipedia. This is the source. It will have a menu with ANSI codes. This explains a bit about how I'm going to use them, because it will be inside the terminal, so I can use like a GUI library. So I'm going to have to write everything in the terminal, and colors will be written using these escape codes. These are some technical details as to what it will be written in, compiled with, and what keys will be used. There's some details as to how I'm going to implement it. And right here, this project will be a TUI frontend. So for simplicity, I'm going to use an already written library by Pascal Pons. It's a Connect4 solver, it's a perfect solver, and it's explained here in this link. This flux diagram shows how the game is going to work. You start right here at start frame, then you have these 4 options, and depending on that, you can save your games in one of 8 different files. If you choose one of these 2, you'll go to a board frame where you'll play the game, and this post frame is when you press X or backspace. It gives you the options to exit the game and return either to start frame or the terminal. And this settings menu will let you choose different colors for the game and the difficulty of the AI you're going to face. And this explains the diagram. These are some of the frames, pictures of the frames. For example, this is start frame. It says welcome, and there's a 4 options, and then post frame shows again the 4 options. This is save games, go back home. This is go to the terminal, and this is return to the game. Right here, this is AI 1 versus 1. Go to save games and settings. Right here, this is the settings frame. This is the AI difficulty, that's why the colors are different. This is the easiest one and the hardest one. These are the colors. This is the default color settings frame, because player 1 is red, player 2 is yellow. Then the board is blue, dark blue, and the column is cyan, the one you choose. You can actually see here the one you choose. You can move with the arrow keys or DNA the chosen column, and that's the color it's shown in. And the winner color is this one right here. When someone already wins, this is shown around the line which won, so that you know that the game is over. And then here, save frame. This is this shows you which of the 8 files for saving are available and which ones already have a game. This first line lets you save the game that you have in the buffer right now in your game, the one you're playing, to a file. This second line lets you go into a file and grab the saved game from that file and continue playing that game. And if you want to free some space to save another game, this last line lets you delete any saved games you may have that you don't want to use anymore. And here, these are the classic colors. I decided these to be the classic colors because you usually see plastic in these colors in the game, so these are the colors. Selected column, it's just like a lighter version of the board, and you can move it with the arrows. Win condition, green is like win, so that's what I chose. Noir is like a darker version of the board. This is a more red tinted version, and this is like some spring colors. And let's see, that should be it. So right here I'm going to copy this, and I am going to clone the repo right here. So as you can see, now the repo has been downloaded, and now we can see in our working directory, which is in this case home, here Connect4. So it should work out of the box since I just cloned it. I'll just cd into Connect4, and if you do list directory, you can see these files. But for now, we just care about this one, start.shell, which we should run, which gives you a loading bar, and when it finishes, it finishes compiling the program, and then it runs the program itself. And here we can see a couple of things. First of all, these are right here you can see the arrows I'm pressing. So if you go to the right and you're already all the way to the right, it flows back to the left, and if you go down, the same thing happens. Up, down, left, you can press any of these arrows, and you can also press WASD. D is right, A is left, S is down, and W is up. And then we can also see that it adapts to the screen size, like that. You can see, like, it, I don't know if you can see it, but it gets smaller, and the text above isn't as dynamic, but it does change conditionally instead of with arguments. So if it's smaller, it fits inside the terminal page. And if we go, say, into settings, these are the default colors, and we'll see when we enter number 1v1 the default colors. And also, having dropped a few pieces, you can see the terminal, the board changes size depending on the terminal. And since Connect4 boards aren't usually rectangular, it just shows you the biggest square it can, instead of just a weird rectangle, since that wouldn't be like good looking. And I can also change, you can see right here, the number of lines, which changes not the window of the terminal itself, but the size of the text. So you can see it gets thicker or thinner depending on that. And right here, it also changes depending on the window. So it's fully resizable, although those two are like the same thing, because it just reads the number of lines, so it doesn't care if it's the same screen size but different lines, or smaller, or anything like that. It just depends on the number of lines and columns it reads. And what else? Let's see, X. You can see here I pressed X. It takes you to the pause screen, which lets you save the game right there and returns you to the previous game. And this saves the game and then returns you to the page. And this one right here, instead of doing that, it just takes you to the current game. So you press that and it takes you here, but it doesn't save anything. You can actually see, if I press this, you can press X, then return here, and you can still see that. But when we go home and save a game and load that game, the game loaded is the one where I last saved. not the one where I press X and then return here. Then again, in the post frame, what you can do is go to save the game, go home to start frame, return to the game, or exit directly to terminal, which is done with an exception, and makes the program save everything and return to the default state and close the buffer so that you can see the past your past terminal history. What else? Right here, these save games are non-volatile, so even if I just exited to term, I can still see the same save games, and if I load this one, I can see it's still the same thing. And right here, if I you can see right here the stuff I told you at the beginning. Save current game, you already saw how that worked with the enter. Load save game, you open the save game you had in the file, and delete save game. If you press enter right here, you can see enter, it prompts you with a warning that you'll delete the file, which is on recover. So it's a good thing that it warns you, because if it didn't, you'd have to, you could just press it once and it would delete your game without you knowing what it did. So that's why it does that. Now let's see, settings, and now let's change some settings. Right here, AI difficulty is set at the hardest, which I'm going to leave at that because I want to show you how it works. And I'm gonna go with a red and blue colors for the players. Then let's make a whiteboard and a black column, and let's say the winner is pink. Now I'm gonna go with right here, let's go home, and now if we go to settings, you can see it's still the same thing we had before. So this is also non-volatile, and with the previous colors we'd already chosen, you can see it drops pretty much immediately. So when I press say that, it also has animation, and since we had it set at the hardest level, it should not be possible to beat this AI, but I'm gonna do the best to try, and let's see how we do. So as you can see, it not only beat me, it humiliated me with 5 in a row, which was to be expected since it's a perfect algorithm, but it has now, since it already won, we can see you return here and it's still there, but you go home and it's no longer there since the game is already finished. And what else? Right here, 1v1, you can see it's still 1 and 1, so the AI doesn't affect it. Depending on what you choose on the menu is what you get, is the game you get to play. Now, as to the structure of the files, we have right here start, which is my bash script for running the program, which, if you see, is it just compiles this, sends it to the background, and then makes a loading bar so that while the process is running, it shows the loading bar, and then it tells you that the compile is done and it runs it, which is what we see right here. And if we see main, what main does is First of all, it has some libraries, some default libraries I included to be able to run the program, and then these ones, the ones that are in like double ticks, are the ones I wrote. So all the ones directly inside of library are the ones I wrote. So like board frame, frame is the parent frame for all of the frames, which inherits, board frame inherits from it. So dot settings frame, start frame, and so on. These are all the frames. Then after that, frame I already explained. Board is the backend for the board. It stores as a vector and as an array the board, and it calls a Pascal Ponce solver to evaluate a certain position. And right here I have some other libraries, which are the key listener, the term listener, and the exit exception. Exit exception is thrown whenever there's an event that merits the terminal to be called, so that you exit directly to terminal. Key listener listens for key presses, and term listener listens for the size of the terminal. Right here we can see this is initializing this variable, this right here, variables, frame pointer, last pressed, and return to term. Gives some indications as to what the program should be doing, and we initialize them right here. Last pressed equals 0 because nothing was pressed. Return to term equals false because you're still in the game. Then start frame is ST is a start frame, which is where the game should start by default, and then our frame pointer is equal to start frame. Then this makes the cursor invisible, this one right here, so that when you have the whole board, you don't have a small red green rectangle, so it just makes it invisible. Then the new buffer opens the buffer, so that when you call clear or something like that, you don't have all your previous history erased, sort of like Vim does right here. You can still scroll, but you call Vim and the whole screen is a new buffer. That's what this does. It calls right here the new buffer, then it catches Ctrl+C so that it can make proper disposal of the files. Then it calls these two threads to create them, key thread and term thread. Then this runs while return to term is false, so that whenever return to term equals true, it will remove these two files where you store the current the volatile files, and then delete buffer returns this right here. When you press CC, it returns to the term, deleting Vim's buffer. That's what this does, but for my program. And then tput-cvvis returns the cursor, so that you're not stuck with an invisible cursor, and then return 0. Now right here, this is Ctrl+C. What it does is return to term equals true. Then keys listens to each key with the key listener, and then let's see, term right here. Term has a size, a pair of size, which is x, y, and the term listener, and what it does is update whenever it changes, so that the pair is always equal to the dimension, and whenever it changes, it prints a new frame, so that it's always accurate. so that the size is always accurate. And right here it checks if the key is different, or I mean if a key was pressed and no action has been done about it, and it tries this, which is either escape, select, or move, and if any of those throw an exit exception, return to term equals true, and it closes the thread. And then it says the last pressed key is 0 because I have now acted upon the key that you wanted me to act upon. And then what it does is print the frame again, like right here it prints the new frame, but this one prints it whenever the size changes, and this one whenever a key is pressed. And that should be it for main. And we see actually right here we can see home Connect4. These are the images I showed you in GitHub, which is some of the examples for how it looks and how it should work. And then controller is just a small program for an Arduino controller with a joystick shield, and the default license, GNU v3 license, and README, which is in GitHub, and libraries. I'll just cd into libraries, and you can see these are all the frames and libraries I wrote, each one with a C++ file and a header file. And then if you see what files are in text, you can see each of the 8 saved files, so to say. And this is part of Pascal Ponce's solver. It's an opening book file, and settings.txt is where I store all the settings. And if you list solver, these are his files. The only one I call directly is solver. Everything else is done from within his own folder, so that everything that you see here is mine. And then there's a call directly to solver, and inside this solver folder everything is handled internally. So that should be it.